I think that most of us prefer that somebody has tested something before we need it to work. The only way that we end up frustrated with computers, or that I do, is when it does something and it doesn't do what you think it should. We have computers and microprocessors and more things. We're having more and more specialized software. We have embedded domains like self-driving cars, but we also just have more and more software that runs on your smartphone. We end up more and more reliant on software for even the simplest of things. My research mostly involves software testing, and it also involves testing software testing tools. Is studying how to make it easier to make higher quality software faster. Ultimately, our goal is to make it easier to tell when we're done, when we've written some software that does the thing that we want it to do. One really neat process that's come along is called continuous delivery. The idea is that if continuous integration is going to allow us to check the quality of our code automatically and frequently, if we can rely on those results, then we can take a passing build and just directly go ahead and ship it out to our customers and to our users. In one project, we're trying to understand how to improve and mitigate this problem called flaky tests. Flaky tests are tests that can pass or fail non-deterministically, which is to say, without making any change to the code, you just run the test and the test fails. And you run it again, the test passes. These are extremely frustrating. A test that has this kind of random failure 1 in 1,000 times might fail every single day because you're running those tests thousands of times. So we're studying ways to proactively detect which tests might be likely to become flaky in the future and how to reduce this flakiness so that the results can be more reliable for the developers who depend on them. As we prove our results on our own research projects, we're also extremely excited to take these ideas and bring them into other domains. There are computational biologists, physicists. More and more people are making software who may not have previously considered themselves to be, quote unquote, computer scientists or software engineers. Testing is not going to be perfect. It's not going to guarantee that we find everything that's broken, but if we write good tests, we'll be able to at least have some confidence. And that's part of why it's so exciting to be working on this problem, because we know that we have this path to impact to improve not only our own research community, but academic software more broadly.